Ernesto Sanchez. Thank you for being here. I appreciate this. This is an early morning Saturday, and people were having, dining and whining yesterday to very late hours, and I appreciate this. I had my presentation this early morning, and I decided to leave it untouched because the way it was correct. So I would like to thank the organizers of this rooted meeting. Joel is not here, but my presentation is on behalf of both of us. And if I say both of us, it is because it is Joel's work also as it is my work. This is hardware hacking. That's my table, my desk, and everything has been organized for the picture. I have very many devices on top of my desk to use this for good things, doing good, contributing to enhance information. And I love to have this, and I love to share with all of you and all of the community what I do. Don't be bad guys, please. And of course, with what I'm going to tell you, you can do whatever you feel about doing, but of course, please do good things with that. So I'm going to start now. We have a problem, a software problem, perhaps. We'll see. I was looking for batteries, and now I have low batteries. Anyway, I'm going to continue while I change the batteries. As you know, Joel Serna, who's not here with us, is fighting in security issues in airlines. My name is Joel Serna. Security issues regarding radio broadcasting and cell phones and mobile phones. I am based on security of radio broadcasting. Do it yourself. As it was said before during the panel session, hackers and hacking for us, it's a way of thinking that it's information technology, and of course this is not working as usual. Whenever we need something, it doesn't work. So, as I said, the old school hackers said that everything is out of curiosity. As human beings, the curiosity and the way of living, we could be a hacker without being an information technology expert. I know hackers who are not in the field of information technology, and I don't know, it doesn't work. Let's see why.
Ahora parecía que sí, pero no. Ahora. Vale, aquí
it works, and here you have a summary. We have presented three parts. First of the is where we are, where do we come from, where we would like to go, to tell you where we come from, what we do, how we're hacking, issues, to explain how it's done. Here we are concentrating on one issue. This is a very broad issue, hardware hacking, for you to work on that and to experiment with this, like tinkering with all those things. And we're going to use this for good things. Once we have had this hacking, this is the first thing. Where do we come from? Where would we like to go? And why we've done this? And with what? With what? And in the end, what we've done is this video system. This is part of your presentation. It looks very huge, but this is a tiny device. It's a tiny device. It looks like a credit card. You can have it inside your wallet, and if you would like to come and take a look at it, it's easy. Where does it come from, those small devices? Joel and I were known because we gave some information on USB and things. We presented remote control items and Wi-Fi issues. And then there was a moment when we decided to add a screen and to have a keyboard, to have something we could configure. And we bought the material to assemble this with all the cables, and in search for excellence and in search for that, because someone else should have had the same idea, to add a screen and add some buttons to it. And of course, yes, that had already been invented. This is the idea we had. It is what we were about to construct. So if it was already available for games. But why not? Someone had done this. So let's work on this and let's work with this and how to hack this free hardware thing to amuse ourselves and to train ourselves. This is an easy way to control and check our results. This is something we take for granted. You can take it as the book you had in high school where you gave results at the end and the answers. It was very easy to see if we've got the proper answer. We have a source code that's free and everything, and we can control if solutions were correct. And of course, it's much more, it's easier, and it's a very, I would say, rewarding things to do. So the important thing is then there is a huge community. There are very many people of developing this, developers of Arduboy. It's something that makes sense. And then we have the Arduino community, big communities, and we have Arduboy and we have Arduino, and they will be willing to help us. I still have problems with my batteries as usual. So hardware hacking. Why do we consider this as hacking? Because in the end, this is just a small device that we are controlling for cybersecurity issues. And this is speech. Well, it's fun, it's cool, it's fine, it's a nice hardware. Because if you don't like it, you can just throw it against the wall and kick it out of your place, because it's not very expensive. We're not going to talk about advanced systems and complex systems. We're not going to talk about acid treating the integrated circuits. No, it is outside of what we, general public, would like to have. And let's be hands-on here. Hands-on, and let's go into the sort of core subject. After the introduction, we have this small device, beautiful device. As I said, it looks great. So to have an idea, it looks like a credit card, as big as a credit card. And it is as thick as 3 credit cards put together. That's it. And as I said before, we're going to be very, in general terms, what we have to do is we have to access a circuit. And of course, we have the screws, some security, some safety screws, and that I don't know who's selling the screws, but that looks fine when you have a screw that is in general, it's they're very expensive. The screws are very expensive, and the devices to manipulate them are very expensive too. And someone had the idea that that was a good idea, and they're selling this as a physical mode of adding security to it. And we have 100 keys here, and it will cost $10 only. $10. It's not very, very, very safe, but I'd like to say that there are specialized companies. You can order the head you would like to have. You can use, well, the problem is that if you use a screwdriver to take it out, you destroy the whole thing. We have bolts, we have protections, we have different types of solutions. You could use drills, and with a drill you can take it out. It could look a bit violent or a bit tough mode of doing this, but we should have to analyze that we're going to destroy some of the devices we're going to hack. And please, so that's it. You have to invest on hardware. And then we have, as we see, the sort of sealed carcasses looking like they have no screws. It is because they're sealed. They are with hot temperature and ultrasound. And the only way to open this is to break them, but you don't need. You can. I've seen people trying to use very, I would say, different methods. You just use knife, and you give just the 4 little coins. You just use the glue, and it is okay. So it looks like if no one had manipulated it. And those anti-tampering systems are the carcass. The truth is that you have a RAM memory, you have the internal configuration of the device, you have an internal battery, and what happens with this anti-tamper system, when you open the box, the switch is open, and in general, as it is a volatile memory, everything is destroyed, everything is disappearing. We need several, because the first one, we will have the tamper solution, and then you have to have a clip, you have to use a small piece of iron, whatever, to hack, as a hacker, to behave as a hacker, and then seals. They are to protect the. Well, it's just that when you access, you cannot have the possibility of getting the guarantee, or it is. They say, well, this is not valid. If you had manipulated it, you cannot repair it. The manufacturer would not repair it. This is what the manufacturer guarantees, so it doesn't matter. And then we have protections with resin, epoxy resin. Here, the circuits are protected. It looks like a good system, but it is done in general with glue or whatever that are not for that purpose. And here you have to think, and it is to do it with care. In the case of silicone, well, you have to take it in a very, very subtle mode. You could use a hair dryer, you could use a blower, you could use something, and it is doing it in a very, very subtle way, to do it with care, to do it with love, to touch it gently. Of course. And here we have painting to identify here what has this red color. It's a ciphering thing. David mentioned this before, and he mentioned Cold War, and that cryptographic device is painted in red, not to allow us to have access to it. That comes from the Crypto Museum. Very interesting page if you want to analyze encrypted devices. You could invest hours, days even, because thanks to the Crypto Museum, to this picture, and thanks, David, for making me think about it. It's like the seed of evil. Okay. And here we have the circuit, and now what we have to do is to see what the heck, what's inside. We have the chips and so on, and we have to identify the integrated circuits, first of all, that are the core of it. And then those integrated circuits are those that will tell us what's inside. And then you can see here the picture of the Arduboy inside. The advantage is that we have all the information necessary about it. In some cases, the circuits have been erased. In other picture, you see how they have taken this and they just destroyed the reference, just scratching on top of it. And then in these cases, this is going to be tough, but we need to measure voltage. We have to know where everything is connected. We have to look for data sheets. That is important. We have to do it with gut feeling, intuition, because in general you think how it's been connected, you know about earthing. You have to take the data sheet of the manufacturing, and there are chips where there are no information. It happens with Chinese hardware, the copies they do all the time, and there is no information about it. So there are chips without any reference, because that's a parrot copy of one that is, of course, approved. Of course, there is no information about it. And this is a nice way to steal things. And as you see here, we have to say if this is an integrated system, a microcontroller, and so on and so forth. We need to know, and we have to test and the test pads are, as we see here, perfectly defined. Those are the circuits you have inside. All the hardware, in general, they will have different pads to test this at the manufacturing plant, or it is what the experts from the company do when they have a client service offered to repair the device. That's what happens. What other components are interesting? And we will know about the hardware. If there are antennas, well, of course, if you have antennas, then the next thing will be that's a radio circuit to just to broadcast or to download the information. So we need to know about the regulation, and here we have some quartz crystals. I mentioned before they had destroyed the marks. It is not to show whatsoever. It's not done on purpose. It's not I didn't do it myself. It was like this, no references, no nothing, no reference at all. And then we have to, all of a sudden, we could say this is a generic plate inside a commercial hardware. We could say this is a generic purpose. All the different pins of the micro are targeted towards the going out of this. It is like the Arduino, but it's a different type. The oscillator is at 18 megahertz. And we'll have an idea on the circuits, the velocity, the speed. And then we have here some regulation circuits, 5 volts, and here what's not seen here, it is a controller RS45 to have an idea that in general this looks like a developer tool to control things, and it is what it was. The micro, you have to see what it is, you have to deduct this out of the pins, and this is what I'm still working on. And I need your help. If you want to help me, more than welcome. And here, having identified the hardware and the connections, that comes from an article that's very interesting regarding reversing and hardware hacking of the alarm system. I have deleted here the names, and I am not mentioning brands here. You can imagine, of course, but I've deleted the names. I would like to say that you have to take this with a pinch of salt. It looks reiterative, but take care of the information and what we convey, because in general, hackers could just go and they could destroy the alarms while trying to breach and trying to, for instance, trespass and get into your place if you have an alarm. So, and it is not good to go against companies based in our country. They have big lawyers, and they could file a claim, and we'll see what happens. Perhaps nothing will happen, but in the end, you'll be years and years, really, and sorry for saying that, fucked up. And then we have here the alarm, and we have here antennas, and we could have an idea on this and what's working, what's not working. You have here the idea and the interface we mentioned before. The modem is a 3G modem. There is a SIM card inside, and we see there is a network port here. We have here the power system, and we have, it's a bit blurred image, but this is a type of switch. And when you open this, it is totally destroyed. It is totally erased. No information available when you open this. And if we've done our homework well, and I mentioned Arduboy and the video games, this is the original circuit from the documentation we got. We have to be very patient with the tester, very patient, patiently. We have drawn everything, and you see there is a microprocessor. As we see here, we have this LED plate that's communicating through the bus with the micro system. We have the power system, we have the batteries, we have the on and off thing, and we have here to what it was connected. The hardware is already there. The hardware has been reverted, so to speak. We know that it works, it starts working properly, and well, we say great, fantastic. And then now you can just download information from the website. You know how it is. And now, how to facilitate the developing, and we have to upload something because there is the interface. We have some programmers interfaces, and we could do it directly. But the thing is that normally is to have the bootloader and this developer IDE, and it is important. And the bootloader, we will see. The bootloader is to load software on the device, on the firmware. And then the bootloader is the first one to start. The first to start is a bootloader. It communicates through the USB port, and they say, I've got the order of reprogramming things, so I move up to the main program. In the case of a thing, it is connected to the computer. They say, well, okay, send me the program, and I will write. The bootloader is one of those executable type viruses, and what happens is that if there is no order to reprogramming things, then this bootloader will reduce the capacity of the main program. Okay, so it could be very obvious because we used to work here in terabytes, gigabytes, but the truth is that those micro things, they have, I'm talking about 1024 bytes of RAM, 350 or 300 characters, 250 characters of RAM memory. So you are destroying a quarter of the system. And then we have to do it gently. And don't forget that those are not microprocessors. Those are microcontrollers. Those are single-task things, single-task devices. You cannot say, okay, or you would put it at rest, and this will stop. There are other multi-task things, but for that, we have to say that I have to take rest in the evening, so I haven't started yet with the multitask things. When you're programming this, don't forget, there might be mistakes. There are people that are destroying the RAM memory, and they say, you have reserved 48 bytes of RAM, and there is no RAM left, not enough. Here, it is Arduino, and we have to say, hi world, with the... Have you used Arduino? Raise your hands. Many of you. For those not knowing Arduino, I will explain quickly what it is, the way it works. We see here the IDE. We see the integrated development environment here, the way it works. And we have the setup and the loop. The setup is the code we will use that is used only once. And the loop, it's always used. If not, you have to stop, because if not, it's in loop. It will be once and again executed. Setup is executed only once. We have to initialize variables. We have communication ports, we have pins, and with the loop and the external functions, we can develop new functions, not to repeat code, and so on. We're talking about RAM and the capacity, but we have to have the economy of the code. We have to try to do it gently and to do it well.
As I said before, what we've done, we have the specifically library for Arduino, so we're not going to invent the wheel here. So we based on the arguments we have on the screen to do a print and say, hey world, hello world. So the example is very silly maybe, but the first time you take the video console and you type, hello Ernesto, and you turn it on, you say, oh my God, that's beautiful. Okay, now we have the console that has been hacked. The console says to you, hi, how are you? And then, of course, you can use it for more useful things instead of being there just playing with it. So what do we use this for? The first thing that came to our mind was a password manager through hardware. blue team, as we call it. So we have a menu with the passwords. So I've always felt bad when a customer asks me to come up with the secure password. I'm always there, and there's always looking at you, maybe just, like eavesdropping, sort of speaking. So what we can do, I said to myself, let's see how this behave as USB. So we have this little menu with passwords on the screen acting as a keyboard. This is our customer, the server password. So you put it there, and those looking at you just pulled a console from his pocket, and he's going to be looking at you like puzzled. But the practical thing is, if you lose this, if you don't know where it is, you can read it, and the passwords will be stored all together. So this is a security breach that is very important. Someone can open it to see passwords. So what we can do is to activate the switch to avoid reading, so to protect it. So it's very useful to use this calculator, this fuse calculator. Probably someone knows about this, but this is smart. You can use this fuse calculator. I don't know if you can read this on the screen, but we have a serial number, etc. It's a little bit bizarre, but at the end of the day, what this is telling you that you're not going to be able to read this, and this is an additional security feature. You could use the micro, read the RAM. You can do that, but you will have to invest a great deal to get your passwords from a video console. So let me show you what the code is live, actually. I'm not going to talk much about codes, but if you're interested in codes, you will have my Twitter account. You can ask me, no problem. I'll answer this to you. So we had this with the pages. You can include your username, but this is like a keyboard. Username, password, or just the password. This is what you can get if you use this. So what we can do is, so we have this CMake menu. So if you have doubts or questions, you can download. This is easy to do. So you have a set off that is secured. This is an emergency button. If you see, this could be stolen from you, so you will have your video console that will be blocked. You will have a pin when you want to open it. Okay, so we have this feature, send to keyboard. The code is very long, so we have a keyboard library so that it behaves like a keyboard, USB, that we've been discussing before, so we're not going to go into all the details about that. This is nice for all passwords. I think it is useful. For my job, it's useful. I use this to store all my customers' passwords. It might be silly, it might seem silly, but I have a long list of secured passwords. If someone is looking at you from behind, this is not okay. But you can do this because this is easy to do and good to do. And then we have a bad USB with a menu so that you can choose the attack on it in a dynamic way. So it's nice. So we decided to create a demo. I've never liked live demos. I've always recorded them beforehand. So let's try to do that live anyways here. Let's see what it is like.
Tanto la de Blue Team como la de...
Both blue team and red team. Okay, here we are. This is the camera. The first thing is we will show you the blue team for you to see the password management and how it works. This is the video console, which is very nice, actually. Can you see that? Yeah. Password, and then you get the PIN number, the number. So you have different possibilities, up, down, right, left, whatever. You push enter, and you see here the menu with the clients, customers, servers, and Twitter.
Entonces lo que vamos a hacer es...
So we log on Twitter. I created an account that I will delete after that. So Rudy 2019. I'm very boring to come up with names, but maybe nobody thought about this name. So we connect the USB, and then we connect the USB to the computer. Yeah, here's the port. So when I have many screens, I always lose my pointer mouse. So password, we programmed this as a keyboard, so we decided to use it as a keyboard, enter. So when we hit the key, we'll see that. So you would write your password here, and then you are in. But this is not the case. I don't know exactly what is happening now. Probably the cable was not well connected. It was my mistake. I'm sorry about that, says the speaker. So automatic, the password, login. Now I see on the screen that this is not correct, but believe me, I tested this earlier this morning at 2 a.m. and it was working okay. But this is live. I'll do that again later, no problem. As you can see, the password was accepted even if it was not valid, because it was stolen my mobile phone the other day and I decided to change all passwords. Probably this is the reason why. Who knows that? And then we have bad USB, this section here. You see a PIN is requested, and you have several tests, Windows, Linux, and different kinds of attacks could be added here. Let's see if it works now.
y si esto le apetece.
Okay, let's see if it works now.
Aquí tenemos la POC de...
Okay, here we are. Cam. Other cam is here. Believe me, I go crazy when I have several screens in front of me. Believe me, so here you are. It's a little blur, but then we have Windows with a notepad, Linux with a notepad for Windows and for Linux. So you start, you execute, you note, and then that's it. That should be like that, as simple as that. Let's try once again. Linus Notepad. As you can see, I was going slowly. I don't know why it's in uppercase. The advantage is that you can repeat it. Yeah, it was uppercase because I hit the key. So it's like a keyboard. If you block uppercase, well, your uppercase will be blocked.
Vamos a ver, POC Linux, bloque de notas. Modifique la del bloque de notas.
So I modified the notepad in order to have an Xterm, and we would have a console to execute anything we would want. I have the key uppercase blocked and unblocked again. As you can see, it works. Again, this is life. If you want to take a look, no problem, but I'll be famous after that. I know that. Future improvement. This is a good idea in order to think towards the future and things that can be improved. It would be interesting to have a library to manage menus. It's horrible. It's hell to come up with menus. I really like it, but making menus and creating menus is awful. So the idea is to have a library with structure in order for this to be scalable and to be used for other projects, not only for those tasks. Another idea is to include Wi-Fi, because we have testing here, so we would have Wi-Fi, Bluetooth, SD microchip in order to store things, so make it scalable, not only use the current hardware, but having the possibility of enhancing it. I would like to thank all the people here on the screen, but also these people are in the first row. So thank you for having proposed improvements, and thank you for putting up with me. It is very difficult sometimes. I know that. I'm a little bit of a freaky guy, but I know it's hard to put up with me. Thank you, and thank you all very much for having come to Rooted. It's an honor for me to see how many people sitting together for me. So now, if you have questions, let's move to questions now. If you want to ask questions or ask for clarifications. So if you have questions, please go to the mics on both sides of the stage. If you have questions for Ernesto. Yeah, there's one question here. The question I wanted to ask you is that you had something to avoid accessing your memory for not having passwords. So if you have this sorted out before, if you cipher and decipher them, the thing is that you will be able to code them and to have a very basic system, but the basic system will not support other things. So the encrypting and uncrypting thing you will have, I mean, for you to use this, you will have a password and you will have to store it somewhere. And the problem would be longer, but the problem will stay there. So the best thing is to use something to avoid and prevent people from entering instead of encrypting. Any other question? Okay, Ernesto, thank you very much for your participation and for sharing with us. Thank you.